Why is this pile of old rotting food hotter than a fresh cup of coffee? Apple cores, coffee grounds, and eggshells. We throw these things away every single day. But I noticed something fascinating. If you leave them in a plastic bag, they rot and smell awful. Yet out here in my garden, they transform into rich, sweet-smelling soil. How does that happen? I decided to test this right here on the farm, inside my own wooden compost bin. It turns out true composting is not just rotting. It is a highly orchestrated process of biological engineering. To start the experiment, I learned we need a golden ratio of specific chemical ingredients. I carefully mix nitrogen-rich greens, like these fresh vegetable scraps, with carbon-rich browns, like dry autumn leaves. The greens act as the fast-burning fuel, while the dry browns provide the essential physical structure. Once mixed together, the first responders arrive on the scene. Microscopic mesophilic bacteria wake up. I can't see them with my eyes, but they immediately start consuming the simple sugars. As they feast, they generate incredible heat. I checked the temperature after just 2 days. The core of the pile was already warming up. The biological engine of decomposition had officially started. But then the real magic happens. The intense thermal phase of the process kicks in. Thermophilic bacteria take over the pile. These specialized microbes absolutely love extreme blistering heat. I pushed a long metal thermometer deep into the dark center of the compost pile. It read a staggering 140 degrees Fahrenheit, right here on the farm. This intense heat rapidly breaks down tough proteins and actually destroys harmful plant pathogens completely. But here is the unexpected twist I discovered during my daily temperature checks and observations. If the pile gets too hot and densely packed, the good, heat-loving bacteria will suffocate. Without oxygen, anaerobic bacteria take over, creating that horrible, sour garbage smell we all hate. So I use my sturdy pitchfork to turn the pile, physically injecting fresh, cool oxygen. The pile breathes again. Proper aeration is the secret to that sweet, earthy forest smell. As the pile eventually cools down over time, a brand new crew of heavy lifters moves in. Fungi and actinomycetes spread their white, delicate, thread-like webs throughout the decaying organic matter. I used my brass magnifying glass to observe these tiny white fungal structures up close. They dismantle the absolute toughest materials, easily breaking down rigid wood chips, paper, and stems. Finally, the macro-level engineers arrive to finish the job. Earthworms and tiny, crawling arthropods. They physically chew and shred whatever organic material is left, digesting it completely into castings. After several months of methodical testing and patient waiting, the incredible transformation is finally complete. The raw kitchen waste has become humus, an incredibly stable, dark, nutrient-dense carbon sponge. Look closely at this texture. It no longer resembles the original food scraps at all. To show you how it works, I poured a cup of water over regular dry dirt. The water just runs right off the hard surface, taking valuable topsoil and nutrients with it. But when I pour water over our finished compost, it absorbs the liquid almost instantly. It holds moisture exactly like a kitchen sponge, keeping delicate plant roots perfectly hydrated underground. It is truly amazing. We took a pile of trash and engineered life-giving fertile soil. The farm is just one giant, beautifully interconnected recycling system that never stops working. Nature never wastes a single thing if the right biological system is put into place. I absolutely love uncovering the hidden mechanics of the natural world right here around us. Tell me, what everyday system or process should we investigate next together on the farm?